everyone, my name is Albin Merle and I am a senior 3D artist and director, mainly in advertising and motion design. I've been working in the industry for over 10 years now, and today I invite you to join me for this series of tutorials for NVIDIA Studio, in which we will learn how to create and animate a cotton yarn in a short and impactful video. For this we will use Blender 3.6 and Geometry Node for the entire modeling, animation and lighting. For rendering, we will use Cycles and its GPU acceleration compatible with NVIDIA hardware. And finally, for compositing, we will work in After Effects, which itself also has compatibility with GPU acceleration. And we can start right away by activating in Blender in Edit Preferences, Systems Optics, and select Enable the GPU. So let's start. In this first part, we'll learn how to create this effect as an asset for future use in our shots. We will do it in steps. Create a vertical strand, duplicate it to have several around it, then duplicate them to form a cylinder. We'll have a distribution that will be rather homogeneous like this. Give them a little randomness also on the height so that we can go from about half of their height to their entire height in a completely random way. And then we'll see. To make the effect of rolling, the folding of each strand, which will be done gradually according to the length of the hair. We also see another effect, which is that we can also have this kind of spiral effect, and that's going to be a small step. So if we deconstruct everything, we create a strand, we duplicate it all around, then we start to give it this spiral and this randomness on the height, and we're going to end up giving it the unwinding. So I hold D to use the drawing tool and right click to erase what I've created, and we can get started. We're going to organize our collections. We can create a mod collection, a light collection, and a camera collection. For organizing our assets, I'll color code them and specify the camera in the collection with a practical ratio. To render, in the mod collection, we create a plane. On top of it, I add an empty curve system. In fact, this curve system is really just a container. I'm going to release it to unparent it. I can delete the plane. It's useless to me anymore. It just gives the info to Cycles that this object can be rendered as a primitive curve. We'll rename it cotton yarn and delete the existing node in the geometry node. I can create a curved line and plug into it. I will make a curved line with a height of 5. If I go into Cycles with Z held and the mouse up, it sees that it actually gave me back this curve. I'll create a node named setCurveRadius. It creates a primitive curve that's ready to render, and I can adjust the settings for now. Now it will show us this 3D curve. I want to bring more light into the world by creating a brighter light. I'm going to 3D here. I'm doing Shift A by selecting the light collection, create light area, set a little bit aside over here, and we're going to give it a little bit of power. That's it. And this curve now, it's rendered as a primitive with an infinite level of detail. That's pretty handy. I'm going back to the spreadsheet to create a table that will be useful for us to understand and see all the attributes we're going to build. Here I go back to Node Geometry, I quit my rendering, I redisplay the overlay with Shift-Alt-Z, and this is the button here. And now I'm removing the setCurveRadius, and we're going to be able to start building our element. So first of all, we're going to make a duplicate element, and then we tell it right away, you're duplicating the splines. It gives me a certain number of them, so I could very well put it here. We can also use another condition called isViewport, which is a Boolean. This condition is just going to help us give a certain amount in viewport and a different amount when rendering. I'm reselecting my curve. So this isViewport condition can be identified because it's pink. Here it's a field boolean, and I'm going to put a switch on it that I switch right away to integer, and at the rendering I'm going to want 256 duplicates of my curve, and at the viewport I only want 128. We can check it right away. When we look in our spreadsheet here, I see that I have 128 splines that are controlled by a root and a head, so we have 256 of them. I store an attribute with the store named attribute, and I'm actually going to store what this node sends back to me. It returns the duplicate index to me. The IDs of each spline range from 0 to 127, as I have 128 splines that have been duplicated, and I can make sure this is the right ID that is stored. Then I look in the viewer column and I see that it has given me the ID of each curve. I'm going to plug in there, switch it to integer. Well, that unplugs it, but I'm getting back into it, and I'm going to call it instance ID. This is an attribute that is stored on points. I'm promoting it on the points by doing that. Behind it, I'm going to create a resample curve node That's a node that allows me to subdivide my curve along its length, and actually it's just going to increment it. I'm going to give it 128. Next step is going to be to give my curve this randomness, right? Since all the curves are all on top of each other, I'll just manipulate them to spread out a bit. We're going to take the attribute we just named, which was called instance ID. We're going to create a combine X, Y, Z node. I create a math node that I put in my quick favorite menu. So for that, actually, we just have to go to any submenu and right-click on the one we want to add in our quick menu available on the Q key. Here, I'm creating a math node, multiply. It's lower a bit, the power of it. A little bit lower coefficient to this ID attribute, and then I'm just going to paste them a little bit more. So there we have 128 vertical lines that all follow, and right behind it, we're going to create the random in height. To do this, I create a node called index. I could have used the instance ID we just built, but it will allow us to discover other nodes. Evaluate a domain. What I'm saying is the input index, I want it to be evaluated well on the splines. Now I really have an ID on each spline that I'm going to plug into the random value in the input ID attribute. So it's going to give me a random value that's going to go from 0.5 to 1 for each ID that it finds, and that's going to put it in a combine node. Either I'm going to look it up here in my quick menu, otherwise I'm duplicating it from what we built just before, and I'm going to put it this time in Z. We're going to create a position node, and we're going to create a vector math node. I connect the position to the first input, and the combine XYZ to the second input, and I change it to multiply. I'll rearrange and create a small group using Ctrl-J, then connect it into the position. I'm going to put it right after that. Not that it puts everything back to 0, and that way we'll be able to see the random in the height, which goes well from half of my height to the whole, and in a completely random way. Let's keep going. I can delete that now. We need to free up some space. Now we're creating an attribute that will gradually build the thickness of our strand, or at least the distribution of the strand, a little bit more in cylinders. For this, I'm going to create and store named attribute node. That's really to keep it out. And it's an attribute on the points, and we're going to store vector, and I'm going to call it distance pose. I create a position node and vector math node, add node in which I'm going to put a very slight value on X, and then I'm going to create a vector rotate node. I add it to my quick menu. I go utilities, vector, vector rotate, right click, add to quick favorite, and there, now I have access here. I connect it into the first input. I'm creating a named attribute node and recalling the instance ID attribute to evaluate on the domain of points. I create a math node, I set it to divide, and then it will actually say that each ID will be divided by the total number of available curves, so I can recall this attribute, which for now is at 128, but at the rendering will be at 256. And a last multiplied node to give a little bit of amplitude, at least to give a coefficient to this value. I store that in my attribute, but if I look at it and plug it directly into the position, we're going to start to see a cylinder forming. And so to have a perfect cylinder, you have to know that this node accepts degrees when you play them directly in the node, but in fact when you connect a field as input, you will have to give it a value converted into radians, and we know that for one turn, it's going to be 2 times pi. And Blender takes care of the rest. Here we have a complete turn with always our randomness on the height. To facilitate the processing of nodes in Geometry Node, in fact, we don't always have to promote and validate each step. This value has been constructed. We don't have to put it in this position. I'll be able to retrieve it and not necessarily visualize it right away. I'll pick it up and we'll look at it later. We'll build everything at once and use one set position at the end. So we continue. Now what we're going to do, we're going to create a vector math node that we're going to switch to multiply. In doubt, I create a little backdrop to put a little more clarity. In the first input, we're going to put our output from the vector math, and in the second input, we're actually going to go up the chain and we're going to create a spline parameter node that will give us several elements. The one we're going to be interested in is the factor that gives us an attribute that goes from 0 to 1 over the entire curve. If I visualize it by doing Ctrl-Shift-Click first on the geometry node and then on the attribute node, I see that I have a gradient that goes from black to white. And actually, it's just the visualization of that attribute that goes from 0 to 1. I'll be able to delete it. I'm going to put it in a float curve. In the input value, I create a small profile. Behind it, I'm going to create an add node because we're going to be able to mix it with a noise, and we're going to build this noise just in question. Combine XYZ, and I plug into both X and Y inputs. We create a named attribute node to have mapping coordinates for our noise. Here I'm going to take the instance ID, noise texture, I connect it in 4D in the W. On the scale, we can reduce it a little bit. We're going to put 250. It'll be fine. Math node that I set to subtract to allow my noise to finally go from 0 to 1. If we visualize it on a curve, it really goes from 0 to 1. At least it oscillates like that. I want it to hover around 0, so I'm going to remove 0.5 from it. Behind it, I'm going to put a math not to give amplitude. It will be just to give a small coefficient if we ever need it, to give more noise or not. I'm going to plug this output into the multiply node that we created just before. We can move on. I'm going to create a node that's called vector rotate. We've already stored it. I'll put the change positions in the first entry. I create a little backdrop around it to have a little more clarity. I make a position node. I separate X, Y, Z. I'm only retrieving the Z coordinates, and that's going to allow me to build this kind of spiral. When we have our curves all going upwards, we'd actually like them to really do this kind of spiral around a central axis. This node will help us start from the Z coordinates. This means that when I'm at a certain position, but the more I go in the air, the more I'm going to have the coordinates that are going to undergo this transformation. I create a math node, multiply, that's to give a little coefficient. We'll be able to change its value right after that. But for now, we can easily put pi twice because we'd like it to make a full turn. I'm going to create an add node so that I can mix it with a noise that we're going to build right underneath it, or that we're going to grab here simply. If I do Shift D, it's still contained in the backdrop. But if I do Alt P, it takes it out of the backdrop. And I'm going to be able to connect it. We'll also be able to change its scale a little bit. Its amplitude, we're going to be able to let it a little bit stronger too. We're going to put 205 for now, and I'm going to plug it into angle. If I create set position, and I look at the positions that we've built that distribute the points to us, that here give us a little bit of finesse at the start, and then finesse at the finish. And there, the rotations all the way up the height of the curve, and now I'm going to get into position. Normally I should have. That's because here I didn't put one. Normally I should have my arm that is formed, and it's all controllable underneath. There will be some rotation here. That's going to be to control the finesse of the curve a little bit. In fact, if we look at it like this curve is actually the profile that I see there. If I exaggerate, I can say if I want it thick at the top, it'll be like this. A sort of cigar-shaped, if not very thick at the base. Or on the contrary, very thick at the base, but which spreads out like this, like a cone. We can keep even this profile, which is not too bad. We can go on. And the same, once again, we don't have to put set position right away, because we're going to continue to put a little bit of noise in our yarn. I'm going to delete with Control X to keep the connection, and keep plugging in with a vector math add. There, I create my little box around it, and I'm going to take spline parameter, I'm going to take the factor that I'm going to connect and multiply. I give it a little bit of intensity, maybe even a little bit more. We put 3. I connect it into an add node that I'm going to mix with a node called the scene time. And that's really going to take in value of my scene, either the frame number or a value in seconds, which will depend on how we're set up here. I'm at 25 frames per second, which means that this node will give me a value of 1, or at least a progressive value that will go up to 1 when I get to the 25th frame. At frame 50, I'll have a value of 2 and so on. I'm making a math node to connect to the second input of the add node. I'm going to take the second one, and I'm going to multiply it by minus 0.5. That's just going to allow me to be able to take the factor all the way through the curve and shift my noise, moving it from the base to the head of the wire. I create a noise texture node. In these 4D coordinates, I plug this little manipulation into the W. I put a small scale. I'm creating a vector math node that I'm passing through subtract to do exactly what we did here, with the subtract 0.5 and a bit of an amplitude behind it. But we're going to do it this time on all 3 axes. That's why we put a vector math. I plug color into the first input. I'm going to put a scale node next, which will be more convenient than changing 3 values of multiply. In fact, the scale node changes all 3 of them at the same time at once. That's my first amplitude node that I'll reduce slightly. Next, I'm going to recreate a scale node that will allow me to set a quantity with the spline parameter throughout the curve. This means that at the base, there will be much less amplitude than at the head, and presto, I just have to plug it in like that. I plug it into the second input of the add and create a little box around it. I'm saving. And then I connect into a set position in the position input. Also, if we look at the animation, we have this hair that can oscillate from the base to the head, and always with a little bit of randomness. That's the first step. We have to create a value that controls this fall off for the hair. So that I'm going to create an attribute that's called the index. On it, evaluate on domain. We're going to force this index to be evaluated on splines. I'm then going to create a white noise that, when in doubt, I will visualize to see what it sends back to me. And normally, I have a random value per curve. For each spline, I have a different value. You can see it in color. It's something that you can get back, even later, to create a little bit of a nice shading, to have each strand with a different intensity. This noise, in fact, I'm going to distribute it neatly around 0 with a subtract 0.5 and then an amplitude. We do everything the same. Subtract 0.5, multiply. I plug into the first input. The multiply, I'm going to set it to 1.5. Behind it, I'm going to recreate a spline parameter. This time, I'm going to take the total length of the spline. I plug length into the second input, and we were able to create a little more readability. That way, if we wanted to save a little space, I'm going to add a second add. And this time, it's going to be something that we're going to control with an input, group input. There, I'm going to promote the attribute, at least this little parameter, in my group input. And I can find it now here. It was named value. I can find it right here. That if I look at it, normally I'm supposed to be able to create a black and white gradient with this attribute, and it's the one that's going to help us control the rotation and the flow of each spline. We can animate that by hand as well, and we'll be able to see that later. I'm going to leave it at acro a little bit more. That way we'll be halfway up and we'll see what happens. That attribute has to be stored somewhere. I'm just going to rename it with the N panel. I'm going to go into group and I'm going to call it a name. I create a new attribute store name. It can be left in float and we can let him work on the points, and we're going to call it fall off, and I plug in. Now that we have that, we're going to be able to move on to building the spline rollout. It's going to be a bit more complicated and longer. We'll have to hang in there. But it's going to be offset point to curve. I set it to I1, so he's going to send me the index of the curved neighbor. But if I get to the base, or the head actually, it's going to give me an index that's going to be curled. That's not what I want. I'd like him to send me exactly the same index as his original index, if there is ever that conflict. If I ever get to the end, or the head of the curve. To do this, I create a small switch node that I switch to integer. In the true index, I leave the index that it sends back to me, and in the false index, the original one, I'm going to force a value to be evaluated on that index. And that's going to be the position of the points that I'm going to ask about the position of the previous point on the curve. Now, I'm going to switch to vector, plug in the input of that node. Next, I'm going to create a subtract node, vector math. In the second one, I put my new position. In the first one, I put my old position. It gives me the difference between the two. In any case, it's going to give me a vector that's going to be the difference of the 2 points. I'm creating a vector rotate node that we've kept in our little quick menu. I'm going to create a vector math node that I'm switching to multiply. And I'm going to create a named attribute node that I'm going to go to instance position. I'll put it in the first entry. I multiply x and y by 1 and leave z at 0 to keep the coordinates flat. I'm going to put them in the axis. I plug him into the first entrance. And now it's just a matter of working on the angle of each point. In any case, depending on the value of the front point. For that, I'm going to create a named attribute node, or just duplicate the one I had here. In it, I'm going to question fall off, which we built just before. I create a math node that I switch to add and that I clamp to keep my values. I create a multiply node. I plug into the first input and create an add node. I plug my add into the first input. The clamp must be removed, and I'm going to plug it into the second input of the multiply. There, I'm going to create an index node. Once again, evaluate on domain. I'm working on splines this time. I'm going to create a white noise node like we had built just before. That little hierarchy. And that we can even recover from elsewhere. We do Shift-D, Alt-P to get out of the block. And I'm going to plug in there. You're going to have to switch it to 4D and plug into the vector and not the W. The W must remain available. And there, it's just going to be there to put a little bit of randomness into the values. We leave it at 0.5. The amplitude, we can put ourselves a little smaller. We plug in well in the add, which fits well in the multiply. And then all of this is going to go into a node that's called accumulate field. And it is he who does all the magic of following up and adding up the values of the previous points. I have him work on a float on the points. The group ID, these will be the splines that I'm going to lay down here. I could have put integer here, by the way. That's what I'm plugging into the first input. And what interests me is the leading value that I connect an angle. That I'm going to be able to put it in another node now. Accumulate field, but this time vector. Work on the points too. This time, it's always the same. It's a work that is done on splines. I'm going to add that. To offset my curves to the right place in the world, I'm going to add it to a node called the curve root. It gives me the position of the root of each curve. It could be a little different. Even if we were a bit at the center of the world, we still have a small gap here. And that's going to give us the ability to put our curves back in the right place. If I don't do that, and we look at the node, we're going to see that they've all been put back in the center of the world. If I give each of them back the little offset they had, we end up with that. And now, we can control the rolling of each hair we've built. That's an animatable parameter. It's also a controllable parameter. We can give more or less, which can be quite interesting, by the way, to have a little randomness in the rolling of the hairs. when you really have a little flexibility like that. Some are going to be a lot looser, others a lot less. Here, we're going to be able to... We won't get 0.5, but it's okay. Here we're going to be able to just say if we want, in the end, the process is much wider or, on the contrary, very, very dry, very constrained. If we want something that happens more outside, we can play with that, which is aesthetically pleasing. And now I'm able to start putting just a little animation key that's going to starting from now, in which at the 250th frame fully unfolded my curve at -5. And I type by on the keyboard so I can place a key. If I look now, I've got my yarn going to unfold. And this in a completely procedural way and without simulation.